Welcome to Penrose Learning, where we make understanding easy.
You start by preparing your environment and gaining access. Make sure your account has API quota and you can reach the cloud backend. Install the vendor SDK now, for example, Python 3. 10+, then pip install Qiskit or the provider package. Next, configure credentials and run a simple connectivity test. This verifies latency and permissions. Once done, load the SDK in a small script, list available backends, and pick a simulator to validate your toolchain before moving to real hardware. Now you construct the quantum program and validate it through simulation. Start by translating your algorithm into gates. Use H for superposition, C0 for entanglement, and parameterized rotations for variational steps. Then add measurements. Simulate with realistic noise models and run enough shots, say 1024, to estimate distributions. Make sure to map logical qubits to hardware topology and apply circuit optimizations to reduce depth. Once the simulated results match expectations, prepare job metadata and resource estimates for the real device run. Finally, submit your compiled job to the chosen backend and monitor progress. Include tags and expected runtime. When results return, post-process immediately, apply calibration correction and read out error mitigation, then aggregate shots to compute metrics. Compare outcomes to simulation and iterate by tuning parameters or ansatz. If you get noisy or nonsensical outputs, first check device status and calibration. If necessary, rerun with reduced circuit depth, change qubit mapping, or increase shots. That single troubleshooting step often recovers valid results quickly.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.